Hello ma'am, how are you? Today I will explain about combinational circuits. So actually combinational circuits are circuit made up of different type of logic gates. It means that this type of circuits are made up of different type of logic gates like AND, OR and etc. In this type of circuit we have n number of inputs and m number of outputs. It means that we can have many inputs and many outputs according to our choice. Output is in this type of circuit, output is dependent upon combination, and in this type also there it does not use any memory, so we should not worry about memory. So this is the diagram of combinational logic circuit. Here 1 to n is the input, and so it means we can have n number of inputs and we can get an m number of outputs. So some examples of some examples of some examples of combination Some example of combinational circuits are multiplexer, decoder, adder and subtractor, code converter, comparator, etc. So today we will study about multiplexer. So multiplexer is the combinational logic circuit designed to switch one of the several input lines to a single common output line, and it is also known as a data selector. We can see this diagram here. So in this we have a four inputs and we have a one output. So in this we can see there is a switch. This is a line which switches randomly. I mean it switches according to S1 and S0. So S1 and S0 determines the output. So this is a diagram of 2 is to 1 multiplexer in which there are two inputs and one output. And this is that figure is of 2 into 1 multiplexer, and it can also shown like this 2 into 1 multiplexer. In this diagram also it is same. So we have a formula: n is equal to 2 raised to power n. Here n is equal to number of inputs and m is equal to number of select lines. For example, if we take m is equal to 2, then n is equal to 2 raised to power 2 is equal to n is equal to 4. So we know that if m is equal to 2, so it will be a 4 is to 1 multiplexer. And the different type of multiplexer are 2 is to 1 multiplexer, 4 is to 1 multiplexer, 8 is to 1 multiplexer, 16 is to 1 multiplexer, 32 into 1 multiplexer. So we will have a study on 4 is to 1 multiplexer. So this is the diagram of 4 is to 1 multiplexer. Here we have 4 inputs and 1 output and 2 select lines. So according to this truth table of this is S1 S0 is this, and inputs are this and this, and this is output. So D node, if we have 0 here, 0 and 0, S1 is equal to 0 and S0 is equal to 0, so we will get the input D node. If this is 0 and this is 1, S1 is equal to 0 and S0 is equal to 1, then we will get D1. If S1 is equal to 1 and S0 is equal to 0, we will get D2. If both are 1, so we will get D3. According to this, we get an algebraic equation D node S1, because 0, there is 0, so we have a line above it, and also S. Sorry, I had done a mistake on this. So wait a minute, we have S node here. Slideshow from current led. So D node S1 and S node is 0, so dash dash plus D1, this D1, S1 dash because 0, S node plus D2 S1 S naught plus D3 S1 S naught. From this we can make the diagram of it. So this is D naught, this is A, B. We will make A and B, then we will have the figure of it. And in this line, D node is D. Here we can see that here is D node. So we should have to have a AND operator, so we can AND operator for AND operator for multiplication. I mean, so if we multiply these three, so we will get this. And if we have this, so it means this d1 s1 dash s naught, and d2 d2 and d2 s1 s naught complement plus d3 s1 s naught is for this. So if we put or get above it, it means we are adding all these small equations into a big equation, so it means output. So so this was the explanation for 4 is to 1 multiplexer. Hope you understand. I tried to explain my best. Thank you. And it also have advantages. It reduces circuit complexity and cost. It can implement many combinations logic circuits using multiplexer. It and also it does not need k-maps and simplification. Thank you.